Namaskar, hello, and once again a very warm welcome to this 5-day online training on development of e-content for teaching and learning of mathematics. My name is Tanvi Khurana. At this moment you're watching us on eVidya channel number 6 to channel number 12. This entire training has been organized by CIET, that is Central Institute of Educational Technology, NCRT, New Delhi. Today we have entered into day 5 and the day 5's topic is developing e-content for teaching and learning of three-dimensional geometry. So far in this series we have discussed that how technology is associated with mathematics and the need, the scope, the free open source softwares and GeoGebra, its features and possibilities. How can one develop the e-content for teaching and learning of calculus and even two-dimensional geometry. Today we have entered into the final day of this entire online training. This entire online training started on 21st of August, that was Monday, and today is 25th of August, the last day, where the quiz link will be released to all of you. You can participate in the quiz, be a part of it, and if you score more than 70% and above marks, you will be getting a participation certificate. I'll be explaining the entire process towards the end of the program, so I would request you to please watch this entire session. If you have any questions, any queries, reach out to us. NCERT Official, that is our YouTube channel where you can watch us live and raise your questions in the live chat box. If you have any questions and you want to share through email, the email ID would be training.helpdesk@cet.nic.in. If you want to give us a call, the number would be 8800440559. Every fourth week of the month is dedicated to specifically for this online training on development of e-content. One more thing, just wanted to clarify, there is no attendance link. So there is no where that you have to mark your attendance. Just be with us and raise your questions. That's all you have to do. And if you scored more than 70% marks in the quiz, then the certificate will be issued to you, but please allow us a 30-day time for the preparation of those certificates. Please have some patience. Thank you so much. So let me please introduce to you our guest for today, and he is Dr. Sukesh A. Sir, a very warm welcome to you.
Thank you and namaskar.
Namaskar, sir. Sir is an assistant professor from Government College of Engineering, Kannur, Kerala. And he'll be explaining each and everything regarding how to develop the e-content for teaching and learning of three-dimensional geometry. So we really hope that you'll be sharing your questions very, very soon. And before we begin this discussion, let me just announce that we are extremely proud of the fact that India assumed G20 presidency and would convene the G20 Leaders Summit for the first time in the country this year, that is 2023. A nation deeply committed to democracy and multilateralism, India's G20 presidency would be a watershed moment in her history, as it seeks to play an important role by finding global, pragmatic solutions for the well-being of all, and in doing so, manifest its true spirit of Vasudhaiva Kutumbakam. Or should I say, the world is one family. Vasudhaiva Kutumbakam also translates to one earth, one family, one future. And that is exactly the theme of this year's India's G20 presidency. So let's begin with this conversation, and let me request sir to please give us the details of how a teacher or anyone who is interested in creating the e-content for 3D geometry. Sir, please help us out here.
Thank you so much, Tanvi ma'am. Before going into the session, I would like to add two comments generally. One is that GeoGebra is a software. It's just a tool to enhance the learning and teaching of mathematics. You should not think of it as a supplement to mathematics. That is, you can't supplement the textbook with this software, but when you're using this, the experience of mathematics is really enhanced. That is one thing that I would like to specify. And the second one is that this is a software. Every software cannot be taught, actually. It can only be learned. So when you want to learn a software, you just need to jump into it. It's just like swimming. Like you jump into the water and learn to swim. You can't learn swim by standing on top of the bank. Okay. So with this comment, let's talk about three-dimensional geometry. So before that, you might have already experienced two-dimensional geometry in the third day, and in the fourth day, you might have experienced the learning of calculus by Ramanujam sir. And so this is the third day where we talk about three-dimensional geometry. So in this screen, if you look at my screen, I have uh, shared, I've opened the GeoGebra window. And if you want to view the three-dimensional graphics pane, you just need to go to view and then click on 3D graphics. So if you can see that in my right side, in the right side of the screen, a 3D plane is already established there. So working on 3D is pretty easy compared to 2D. It is very simple and pretty straightforward. So what you need to do is you just need to click on this 3D window, and then a lot of tools will be available on the top left side. So you suppose you want to create a particular object. Say, for example, if you want to create a cube-like structure, right? So what you need to do is in the 2D graphics pane, you just need to draw a square first. Okay, a square or whatever you want to do. So I'll click on the polygon tool and I'll select the regular polygon option here. So a regular polygon is nothing but a polygon with all the sides same. So I'll just click on the pin, and I'll make two points, say A and B. And then it'll ask me how many vertices do you want. So I'll just say 4 and click on OK. Now, when we click on OK, you can see that there is a polygon that is already created in the graphics pane, two-dimensional graphics pane, and the similar polygon appears in the 3D pane as well. Now, if you want to make this polygon into a cube or something like that, you just click on the 3D pane, and then the 3D tools will appear on top. Okay, from this, if you go to the pyramid group, okay, you can see something called as extrude to prism. So if you click on this and then select in the 3D pane, just select the polygon which you have already made right now. And when you select that, it will ask for altitude. So I'm just entering the number as 4. You can enter whatever number you want, in fact. And if you click on OK, you can see that there is a cube that is already created on the right side. Now, you can, in fact, move this, and you move this cube up. You can change the size. Now, using this rotate 3D graphics view tool, you can in fact turn this picture around, and you can see in different ways what the cube will look like. Right. So this is the basic construction that we do in 3D, three-dimensional geometry. Now, our point here is that if you want to use this for teaching of mathematics, how do you do it? Okay, so what I'm going to do is, there is a problem in NCERT book which says that if you have a box, okay, a box with a fixed volume, what will be the minimum surface area required to cover the box with a wrapper or something like that. Okay, that is a typical problem that you can see in the NCERT book. So what we'll do is we'll try to create an applet with all these, which tries to solve that problem. Okay, now the screen is fresh, everything is new. right? So what I'll do is I'll just try to create a um, yeah, I'll just try to create uh, a box here with all the parameters that whatever we want. Now, in our case, we have already understood that the uh, the problem in hand is that the volume is fixed. Okay, so the volume, say for example, let's take the volume as say 27 or something like that. Okay, so for that volume, I'm creating in the input box. What I'll do is I'll type v is equal to 27. So I have a variable created. You can see this algebra window where the variable created is v is equal to 27. This represents the volume actually. Now, with this in hand, I want to create a box-like structure. Now, a box has three sides, right? Let's call it A, B, and C. Now, what we want is we want to find the surface area of this box. Okay, what I will do is I can change the value of the sides. Say for example, A I can change, B also I can change, and the third side of the box, since the volume is fixed and the volume is always given by A into B into C. A is changing, B is changing, A into B into C is a constant. So obviously the third side should be a function of both the other sides. So for that, what I'll do is I'll click on this a 2D area, and from the past two sessions you might have understood that whatever is changing, that is represented by a slider. Okay, so I'll create a slider for two sides. So the first side, I'll create a slider, say called A, which varies from say 0 to 5 with an increment of 0.01. Okay, so the slider is created, and the second slider, I can call it as say B or something like B, with minimum value of 0 and maximum value of 5 with an increment of 0.01. You can use your own values when you're creating this. I just want to demonstrate that this can be done using, that problem, whatever is in hand, can be solved using GeoGebra in a very neat and fine way. Okay, so I have two sliders which represents two sides, A and B. Now the third side, which is maybe C, can be written as the volume divided by A into B, because A into B into C is equal to the volume, and for volume I already have a variable there. So I'll call C equal to, in the input box I'll type C is equal to V divided by A into B. Okay, so I have the third side as C, which is 27, right, in our specific case. So I have the three sides. Now I need to create the polygon. In the earlier example, we had created a polygon and we had extended or extruded that polygon to a prism. Okay, so what we'll do here is we'll create a polygon with all these sides, say A and B. C will represent the altitude. So for that, what I'll do is I'll create a point. A point can be created in two ways. One, you can select the tool from there, or otherwise in the input box you can simply type 0, 0, which is the coordinates of the first point. And for the second point should come somewhere here with one side as A, okay, in the x-axis. So the coordinates will be A, 0 in the x-axis. So you can see that there is a point B which is already created there with coordinates A and 0. The third point, C, It can be the top right corner, okay, which is one side is already A is created, the other side B we need to incorporate. Okay, so here this point C can be A comma B. Okay, so the third point, sorry, the third point C is simply A comma B. Okay, so you can see that the point C is created there with coordinates A comma B, and then the fourth coordinate we can use 0 comma B, right? So D is also created. So we have 4 points now. 4 points can be joined to create a polygon. So polygon, we in the last example we had used the polygon tool to create it. Otherwise you can use commands to do the same thing. So in the input box I'm just using the command polygon, Polygon, which is the polygon, and in a cyclic manner you need to define the points from A to B to C to D and then return to A. So I have a polygon created here. In the 3D view you can see that this polygon is already there, and I'll just remove this point E, which was created by mistake. Right click on it and delete. You can remove that particular point. So you can see that here this polygon is already created in the 3D graphics view. Okay, right. Now after creating this polygon, I just want to extrude this polygon into I just want to extrude this polygon to create the box. Okay, so I have already created the variable called C, which has the size of this box, right? So what I'll do is I'll click on the pyramid group and extrude to prism, and then I just need to select this polygon. Yeah, when I select this polygon, it will ask for altitude, and I have already created the variable C, which represents the altitude. I'll give C as the input there and simply click on OK. So you can see that the view is already created there. Right. To get the 3D view, I'll just simply close this, maybe. Yeah. Right, you can see that this it is 27, so it is very big actually. Okay. So what I'll do is I'll change these sliders so that, see, if I change this A, that box becomes smaller. If I change B, its size becomes appropriate for the view that we are looking at. Okay, so this is how actually we create the box, right? Fine. You can change the view accordingly, whatever you want, whatever angle you want to view this box from. Okay, so this is how a box can be created. Now, the point is that I want to see the surface area of this whole box. So what I'll do is in the same extrude to prism view, if I go there, there is a button called net. When I select this net button and simply click on this box, you can see that the box is already created there, and a set of all the faces is appearing there. And apart from this, you can see that there is a new slider that is being created in this side in the 2D graphics view. Okay, now suppose I'm changing this slider. You can see that the box is getting covered now. Okay, this is a net command. And I also want you to observe that there is some value here that is called G is equal to 55.45, which is there, and apart from that 0.66. So 0.66 is the value of this slider that is moving. Okay, and apart from that, this G that represents the total surface area of this box now. Okay. Now, if you change the size A and B, I want you to observe the value of G here. If I change the size of A and B, you can see that G is also changing there. So it means that when the sides change with a fixed volume, the surface area is changing. Okay. Now let me just fix the value of A first. So I'll put this as maybe 3. Okay, the value of A I've fixed as 3. Now let me change B and show you what happens. If I change B, what happens is that the value of G is changing 58, it's decreasing. When I increase it, it is decreasing 55, 54.6. Then after 54.03, 54, and then it starts increasing again. So initially you can see that this value is decreasing and then it starts increasing. So I want to find the minimum value of the surface area that is required. Okay, so here you can see that I've reached 54, and before that 54 it was more than 54, and after that 54 it is again greater than 54. So 54 is my minimum value, and I'm obtaining that minimum value at the value of B is equal to 3. So you can see that A is equal to 3, B is equal to 3, and then my height, that is the value of C, that is also equal to 3. It means that in a you get the minimum surface area in a cube. Right. So this can be demonstrated very efficiently using applets like this. So this is one just example that I have done in a demonstration format to show you how this can be used in teaching mathematics effectively. Okay, let me just close this. And I have some applets that I've already created just to demonstrate how it can be used to teaching mathematics. You can create applets like this on your own. The only thing that is that you need to define your problem in hand first, what you want to achieve first, and then using all these tools, you can just simply create whatever applet you want using 2D or 3D or whatever it is. Okay. So here I have an applet which demonstrates the three-dimensional points that is there in the Cartesian geometric system or the Cartesian coordinate system. Okay, so say I have, if you look at this figure here, I've already created this applet, and here you can see that there is a cube that is formed here, and you can see a point here which has some coordinates. Now let me just change these values and show you what happens. Now every point in a Cartesian coordinate system is represented by 3 numbers. Okay, one is called A, the x coordinate, the other is B, the y coordinate, and so on. Okay, so if you look at this A, B, and C, you can see that if I change A, B, and C, then say I have fixed it to 5, 5 and 4.6, and when I click on point, you can see that in the x-axis here, you first go to a distance of 5, and then in the y direction you simply go to a distance of 5, and in the z direction you can go to a distance of 4.6. Okay, it's moving up, and you can see that there is a rectangular kind of shape that is being created there, which represents the point 5, 5 and 4.6. Okay, so like this you can demonstrate the possibility of or the essence of a point in three-dimensional space. Okay, now I'll just close this applet again, and let me go to the conic sections. This is an applet that we had created for our plus one and plus two mathematics laboratory, which we have implemented in Kerala school syllabus for plus one and plus two. So here you can see this is a very beautiful applet which can demonstrate the different conic sections: hyperbola, ellipse, parabola, and circle. Okay, so you can see that in the right side there are two angles. The angle here is marked as alpha. Its value is 30 right now, and there is another angle beta, which is marked as 50. Now, if you change this angle alpha, you can see that you can extend the cone that you're talking about. Okay, now I'll just keep it as 30 degree for the time being, and if you change the angle beta, you can see that the plane is being tilted, right? The plane can be tilted from 0 to 90 degree, and whatever plane, whatever way you want to look at, you can change this 3D graphics view, and you can see that the position of the plane, and you can also peep into the cone to see what the shape is there by intersecting this plane and the cone. Okay, and there is one more slider you can see here. It is the position of the plane. If you change the position of the plane, you move the slider, you can change the position of the plane. Now let's just simply play around this for a little bit. Say for example, if I keep this alpha angle as 30 degree and keep beta as 45 degree, you get an ellipse here, right? The intersection is simply an ellipse. If you peep into this, you can see that it is an ellipse. Now suppose I change this angle, right? If I change this angle beta, what is happening? The ellipse, it is shrinking, 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 and finally when I reach 90 degree, you can see that the intersection becomes a circle, right? And now so 90 degree it is a circle, then all other degrees it is ellipse. Now say what happens if I make it as 35 degree. Okay, 35 degree again is an ellipse, and when I bring it as 30 degree, which is the same as this angle alpha, you can see that I have the intersection is a parabola, right? And if I go below 30, what will happen? Let's see. If I go below 30, it becomes a hyperbola. Means the plane that will intersect in two parts of the cone and create a hyperbola. So this idea can be demonstrated beautifully using this applet. And if you note that today's students, they are always more in visual intelligence rather than audio intelligence and textual intelligence. When we were actually students, we used to dwell more into the text and the audio kind of thing. But today's students are more well versed in visual thinking rather than audio and textual thinking. Okay, so these kind of applets will definitely enhance their view of mathematics. And one specific case is that, see, uh, coordinate systems are not just limited to Cartesian coordinates. Okay, coordinate systems, there are different kinds of coordinate systems. One kind of coordinate system is called the cylindrical coordinate system. Okay, and in the cylindrical coordinate system, yeah, in the cylindrical coordinate system, yeah, there are 3 points again. Instead of x, y, and z, there are three values. One is called the radius r, and the other is an angle alpha, and then the third value is the height. Okay, now I'll just change these values here. I have included some input boxes to just give some numbers. You can change these values if you want. So what I'll do is I'll just change my value of R to say 4, alpha to 45 degree, and maybe Z as 3. And let's see what happens. If I click on this button point, okay, you can see that in the cylindrical system, the r represents the distance, the radius of the cylinder. It comes here, r, and then it sweeps an angle alpha to one side. Okay, so you have r already there, you have an angle alpha, and then it climbs on towards the z-axis for a distance of 3. So a point in a cylindrical system can be represented by the radius of the cylinder plus the arc angle, that is 45 degree, and the altitude, that is in this example it is 3. So you can just create such applets and then demonstrate different kinds of configurations. So how it will look like. Say for example, if I'm changing this angle alpha, instead of 45 degree, suppose I'm making it as say 180 degree. Okay, if I make it as 180 degree, then you can see that again the radius 4 is traversed first, and then after that it goes an angle of 180 degree. It just simply sweeps 180 degree, and 180 degree is obviously a semicircle, and from there it starts to climb up, and it goes to a distance of 3, that is the Z value created here. So this visual picture, it can be actually demonstrated using these kind of applets. Now there is again another system which is always confusing, which is called the spherical system. Now I'll just show an applet related to spherical system. These systems are generally used in physics and engineering to represent electromagnetic fields and so on. Okay, so you can see that in the spherical system, in this applet, you can see that there is a sphere, there is a cone inside that, and then there are some angles. Let's see what happens for this spherical system. So I have an R value which I'll make it as maybe 3 and 45 degree and 45 degree. Let's see how this point will look like. So you can see that a sphere is created here with an with a value of 3, and then the theta value of say 45 degree, and then it sweeps from here to 45 degree. So from here it sweeps, and the point P is obtained here. Right. So these kind of visualizations will help the students to understand more on 3D. Okay, and text is actually limited to 2D, since whatever figure you draw in a text, it is actually limited to 3D, and animations will definitely help you to understand more better. Now, not only coordinate systems, you can use this to visualize maybe integration. You might have already come across this kind of a thing in the last session. Okay, so I have to just demonstrate this integration. Now, suppose I want to find the volume of a cone. Okay. Now, cone is just a combination of a number of cylinders. If you can see this right side, you can see that see the limit of the volume of cylinders, small cylinders which you take here, is actually the volume of the cone. Okay, to demonstrate this, what we'll do is see in the first sense. Suppose I'm creating a sphere, a cylinder inside. I'm embedding a cylinder inside a cone. Okay, now you can see that the volume of cylinders is say 84.82, whereas the volume of cone is 226.19. Okay, now suppose I'm increasing it more. You can see that more and more cylinders are stacked on one upon another, just like the concept of infinitesimal volumes adding up to infinitesimal volumes of cylinders adding up to the volume of the cone. Okay, now I just want you to look at the values here of the volume of cone and volume of cylinders. You can see that the volume of cylinders is 162.86 right now, and the volume of cone is 226.19. Okay, now suppose I'm increasing this number of cylinders inside. Now look at the value of the volume of cone and cylinders. Cone is fixed, but the volume of the cylinders is actually increasing, right? So as and when I make more and more cylinders, when I stack more and more cylinders inside this, obviously the volume is increasing, and in the limiting case, it will definitely become the volume of the code. So this is a very important concept in integration, that in the case of 2D, you might have seen small rectangular strips under a curve, which is the approximation of area. So as you make the width of the or thickness of the strip very small and increase the number of strips, the area is almost approaching the area of the curve. Similarly, here when you look at small volumes of cylinders and then increase the volume, so that the volume of the cylinders in the limiting case will approach to the volume of the cone. Okay, so this is one way we can do this. Now, GeoGebra, it is not only limited to demonstrations in mathematics. You can also use this to demonstrate concepts in physics and so on. Physics, engineering, and things like that. So I'll just give a demonstration, since the time is running short. I'll just give a demonstration in physics that we can use here for to get the idea very clear. So in physics, there is a concept called AC generator, wherein we have a rectangular coil. Okay, you can see that. I'll just show you this inside two magnets. So I have a north pole and I have a south pole. I have a rectangular coil which is rotating inside this north pole and south pole. I can move this slider, and you can see that the rectangular strip is moving inside this, right? Now, okay. Now, suppose I want to demonstrate how much voltage is generated from this. Again, here I have already created this applet so that you can see the in the right side, you can see a graphics 2 pane opening up. Okay, in this graphics 2 pane, you can see that the voltage, you can see the voltage that is developed when the coil is rotating, right? So these kind of applets can be used in physics also to demonstrate such intricate ideas, because all these ideas are seemingly very complicated in the first read, and then this can be used to enhance the whole idea of this. Now, just before winding up, I'll show you one more applet where you can use this to demonstrate the system of equations in linear algebra. Okay, in linear algebra, you know that linear algebra generally deals with matrices, and system of equations are a part of matrices, and let's see what a system of equations looks like. In the case of matrices, you can see understand that a system of equations with three variables, say for example x, y, and z, ax plus by plus cz equal to say d. Okay, like this, there will be three set of equations. Now you want to visualize the solution of all these three set of equations together. Okay, so here I've already created, say, three sliders which represents the coefficients of x, y, and z for the first equation, a1, b1, and c1. Now, if I change this value of a1, b1, and c1, you can see that every a1, b1, c1 equal to d1, it actually represents a plane. Okay, it actually represents a plane. You can twist these views so as to visualize this perfectly. Okay, so I'll just in order to avoid confusions a little bit, I'll just simply switch off all these planes right now. I have only one plane. Okay, so a1x plus b1y plus c1z equal to d1. That is my equation that I'm looking at. Now, if I change the coefficient of a, what will happen? You can see that it actually tilts around a particular axis. Now, suppose I'm changing b1. Again, it tilts around this red axis. Okay, so that is the y axis, and it tilts around that z axis. Y axis. And if you change c1, say I'm moving c1, it actually tilts around the z axis. So a1 x plus b1 y plus c1 z, it is actually representing a plane, and the coefficients represents the tilt. And if you look at this figure in a little bit more detailed fashion, you can see that there is a triangular area that is getting formed inside this. That depends upon the value of a, b, and c. Now, what about d? If you change d, what will happen? See, this triangular area, it actually moves away from the origin. Okay, this is the picture that you get from the one particular equation. Now, if I do the same thing for the second set of equations again, I have one more plane that is created here, and you can see that this plane also, it can be adjusted in such a way that the first one tilts around the x-axis, the second one tilts around the y-axis, and the third coefficient c2, it tilts around the z-axis. Okay. Now, if you try to solve these two set of equations alone, then what would be the solution of these two set of equations? These two set of equations, it actually, you can see that this plane is intersecting somewhere. right? The planes are intersecting somewhere here. So let's see what is the intersection all about. You can see that the intersection is a line. You don't have a unique solution if you have only two set of equations. You just have a set of solutions. A set of solutions means all the points falling under this line is actually the solution of two set of equations. So a unique solution means a solution that has only one value. Okay, solution that has only one value means you need to have a single point. You can't have a line like this. You just need to have a single point. So the intersecting point should be a instead of a line, you need to have a point. So let's take the third plane as well. The third set of equations, again you can see that a violet plane is there, and then if I can tilt this using the coefficients a1, a3 and b3, okay, in the y direction, and c3 in the z direction.
Okay, sir, we just have last 1 minute left.
Yeah, I'm about to finish. Now you can see that the three planes here are actually meeting at a single point here. I'll just switch off this line and show you that single point. This single point is the meeting place of all the three planes, right? So that will be the unique solution for this set of three equations. That is the system of equations. Okay. So since time is limited, I'll just wind up here, and I'm open to questions if there are any.
So you've answered all the questions actually related to the topic. Just wanted to ask any suggestion you have, any advice you have for all the new people who are trying to create content with the help of GeoGebra.
Yeah, the first and foremost advice I would like to give is jump into the software, start using it. Obviously there will be errors, but all the errors, whatever you come across, help is extensively available in the internet. In fact, I would like to quote here, you might have heard of Niels Bohr.
Yes.
Niels Bohr is a physicist who came up with quantum mechanics and so on. There is a famous quote of Niels Bohr saying that an expert is a person who has committed the maximum number of mistakes. So as and when you commit mistakes, you try to learn from each and every mistake from there, and the solution is there with you. So the number of mistakes is actually, if it is very high, it means that you know the solution for all these mistakes, and then you become an expert. So that is the only way to study this, and keep the students in mind, because the students, they are more interested in visual intelligence rather than audio and textual intelligence, and we are teaching to make students learn. It's not to show our knowledge to students. No, it is to make them learn. So give priority to the students first, and then if that priority is set, then obviously whatever they want, we are bound to give them whatever they want. So these are the things that they want. So try to move more into that direction.
Thank you. Thank you so much, sir. I'm sure all the viewers who are watching this, they are going to follow your advice for sure, and they are going to take care of what are the requirements of the children, and they are going to follow each and every step that you told us. Thank you so much, sir. It was a pleasure having you. Thank you. Thank you to all the viewers as well for being a part of this program. I really hope that you have registered yourself. You've participated in the programs that we have for all of you. Let me please give you a brief that about the CIET and this online training. If you open your browser and click on CIET, this is the home page you will see. So in the menu bar, you can see there are a lot of options. If you you go to the events option. The third last option is workshop/training. Once you click on it, scroll it a little further, and in the current activity you will see online training on developing e-content for teaching and learning of mathematics. This is the theme which is going on for this particular week. Please click on it. Once you do, this is all the information regarding this online training. The schedule has been mentioned with each and every date. The topic for every specific date has been mentioned. Please scroll it down. The objectives, who all can participate, the schedule in detail have been mentioned, and here comes the QR code. If you have not registered yourself, please do it right away. Scan this QR code and fill up the information. Please make sure that you are writing the spellings of your names correctly, because they will be used for the certificate. And if you want to click on this link and fill up the information, you can do that. So there are two options. You scroll it further, and here is the quiz link finally released for all of you. You can submit this quiz by 4th of September 2023 by 6 p.m. You have a lot of days, so please go ahead and watch all the sessions that we have done under this online training. This is the YouTube link of the same, NCERT official, that is our YouTube channel. All the 5 sessions that have been done from day 1 to day 5 are here. Please watch them, and you can participate in the quiz. That will be very easy for you. Scroll it a little further, and this is the feedback form. Please submit your feedback if you have any suggestions, any advices, any future topics that you want us to take in this online training. You can please suggest that. And here is our email ID, training.helpdesk@ciet.nic.in. Please ask your questions regarding the online training, regarding the subject, anything you have, not just within the time frame of this program, but later on as well. You can raise your questions. We'll be more than happy to answer all your doubts, all your queries. All the very best to all the viewers for taking part in this quiz. I really hope if you score more than 70% marks, you will be awarded with the participation certificate. So all the very best, and have a great day ahead. We are wrapping up this online training right here, but next month, in the month of September, we'll come back again in the 4th week of the month, and we'll come back on a different topic related to developing of e-content. So here we are wrapping up, but upcoming next is a very special program called Sayog, and the topic of discussion is going to be promoting self-discipline for a successful career. Do raise your questions if you have any. Before leaving, just want to tell you once again that NCERT textbooks for this new academic session 2023-2024, they are available throughout the country. You can either go to directly the sales counter and purchase those textbooks from 9:30 to 6 p.m. The sales counters are open, and if you want to download the PDF version of these books, you can do that from NCERT, Diksha or ePathshala website or their mobile application. Apart from this, if you want to place an order with the help of website, the website is ncrtbooks.ncert.gov.in. Place an order and you'll receive the textbooks at your doorstep in no time with no delivery charge at all. So that'll be all for this particular program. I really hope that you enjoyed this online training. All the very best. Once again, I'm Tanvi Khurana. I'll take a leave of you. Namaskar.